All right, thank you all for joining us. We're going to get started here in just a second. Why DX systems fail. We're going to give you a quick 15-minute rundown of our experience and hopefully get something out of that. And then Eric's going to talk a little bit about his new position at AAON and how he may be able to get you some more training. And I will talk to you about a little bit of stuff going on at Insight Partners. So I'm going to get these screens all lined up here to do presentation mode. Let's see here. All right, well, thank you again, everybody, for joining us. I am Tony Mormino with Insight Partners. I'm the Technical Sales and Marketing Director here at Insight, and I have with me Eric Norris. Eric, would you like to introduce yourself real quick?
Sure. I'm the Technical Training Manager for AAON. I do some classes we're going to discuss a little bit later in this presentation for engineers and design build contractors.
Awesome, and thanks for joining me today. I appreciate it. So this is a new thing we're going to start doing on LinkedIn. We do these long, hour-long PDH seminars, which are great, but a lot of people just want, hey, get on here for 15 minutes and show me something I care about. So I'm calling these little segments the 15-minute quick take. So we're going to put a little timer on here. We're going to give you some information, and then we'll talk. If you want to hang out and ask questions, please do. You can always put questions in the chat. And what we'll do is at the end, we'll address the questions. We'll knock out this 15 minutes, and then we'll do that and tell you a little bit about what's going on. So I'm going to start the timer so you and we know that we're on track. So the topic today, very basic, like why DX systems fail to control humidity. And the basic problem is most DX systems are designed to look at the sensible temperature in the space only. They look at a thermostat. If it gets too hot, it brings on the compressor. It dehumidifies the air. It cools it down. It satisfies the temperature in space, then it turns off. And while it's off, this might be a big shock. It doesn't do much dehumidification. So let's walk through a basic air handling system, mixed air 8067, which is pretty common, which happens to be a 59-degree dew point. And the reason I'm showing you the dew point is this. If you want to dehumidify the air, the coil needs to be colder than the dew point of the air, okay? So in a standard system, let's say your coil is 42 degrees. Eric, are you still there?
I'm still here. Looks like your video is frozen. We can hear you well.
Hold on one second. Take it away from here and walk through this system.
All right. So the system we've got here, this is going to be an on-off system. We've got 8067 entering our cooling coil. So that's going to be your mixed air condition. We're going to cool that air down to about 52 off of the coil, give or take a little bit. Then we've got some motor heat that is added in because this is a draw-through unit. That motor is going to add heat, and in this case, we're showing it with about 3 degrees of heat. So we're going to provide 55-degree air into the space at that 52-degree dew point. So when we go to part load, things are going to change a little bit. And it looks like Tony's back up with video going. So I'll let you take it over again, Tony.
You never know what's going to happen when you do these things live. I hope that doesn't happen again, but we'll see what happens. Okay, so I don't know where you got to on this, but basically, if you're looking at the temperature in the space only, and you blow 55-degree air in there, and it's sunny and it's hot out, and there's a lot of people in the space, that's great. But what happens is, when it's not sunny, when it's part load, which is denoted by the dancing cloud, then the 55-degree air is going to be too cold, right? And your system's going to shut off. And again, when it shuts off, you don't dehumidify. So it doesn't know the humidity in the space is building because it's only looking at sensible temperature. And therein lies the issue with standard DX HVAC equipment. And to understand this, you really just have to understand what happens at part load. So if you have this space, it's a summer July day, it's hot, there's a bunch of people in there, the sun's shining in, and your AC unit's pumping out 50, 52-degree air, 53-degree air, it's fine. You want that cold air. What happens in October when it's cool and rainy and you have a bunch of people in the space, the humidity's going up, but it's cool. Your system's not going to come on because it doesn't need the cold air, so it's not going to dehumidify. And that is what we call part load. And most systems are designed for full load conditions. Eric, any comments on that?
Yeah, one of the other thing that's going to happen, especially if you're using on-off compressors, is your temperature is going to fluctuate based on the deadband of your thermostat, along with any time delays, because you've got a minimum run time and a minimum off time for that compressor. And if you're at a real part load type situation, you may end up running the compressor longer than you really want to and overcooling the space even at that point. And you have no control of relative humidity in that case.
Which makes it even worse. Yep.
That's right.
Okay, so the challenge then is to have a system where you're controlling temperature and humidity over all load conditions, if that's important to you. You know, maybe a standard office, it's not that big of a deal, and a residential application, it's not that big a deal. But we do a lot of situations like labs or schools and stuff like that, auditoriums, churches, where it's important to control temperature and humidity over all load conditions. So I'm shifting from the standard unit to a more, I don't want to use the word custom, but a unit that's designed to dehumidify the air. And I've added two components to the standard unit, the reheat coil, which is shown here, and a temperature/humidity sensor. So what's important about a temperature and humidity sensor is it allows us to calculate the dew point in the space. And the dew point is an excellent indicator of the amount of moisture in the space, much better than the relative humidity. So if we look at that on a psychometric chart, on this particular psych chart, the dew point temperatures are here, highlighted in yellow. And let's say we want to control the space dew point to 55 degrees, which is pretty standard. So if we draw this line here at 55-degree dew point, if we're measuring a space condition above 55-degree dew point, then we go into what's called a dehumidification mode. Okay? So what does that look like? Well, let's take your standard air we had before of 80, 67, 59-degree dew point. We are now in what we call a dehumidification mode. So we want that coil to be very cold. Let's say we're controlling it to, what's a standard control point, 45 degrees-ish, Eric, would you say?
For your suction, 45 is pretty common, and that would put you in the low to mid 50s for your coil leaving air temperature.
Right, so if you got low to mid 50s, you're really wringing out that moisture out of the air. It's flowing into your drain pan. If everything's working right, it's flowing out of your building, so you're dehumidifying there. All the dehumidification is happening in the cooling coil. What happens is, again, on part load, you may not need 52-degree air in the space because it may be too cold. So what we do is we reheat that air. The energy we pulled out of the air to dehumidify it normally gets rejected to the condensing unit outside to the atmosphere. Now we're going to take that heat, bring it back in, and reheat the air. Now this 68 degrees is an arbitrary number I picked. You want to have a modulating reheat coil to really reheat along the sensible line when you need it, and that is calculated based on the space temperature. This would represent a very extreme part load condition if you're trying to reach 72 degrees in the space. And I will point out that all the dehumidification happens in your cooling coil, not in the reheat coil. The reheat coil is a sensible only device. So then we pick up a few degrees in the fan. It blows into your space at 70 degrees, 52% RH and 52-degree dew point, and that would be a very low load condition. Any comments, Eric?
Yeah. We show 68 degrees off of that reheat coil and then 70 off of the fan, and that would be a pretty extreme part load day. You'd have very low sensible load in the space. By using a modulating coil on the reheat, you can now just dial in exactly what leaving air temperature you need at that 52-degree dew point to control both the space temperature and the space humidity at the same time and keep a room that is consistently the same temperature, the same humidity, so the same comfort level very consistently.
Well said. I could not have said it better. Okay, so moving along, let's look at what this looks at like on the psychometric chart. So the dehumidification sequence looks like this. If we take our scenario of 80, 67, we plot it on the psych chart. We have 80 degrees dry bulb, which is here. And this is a little, hard for you to see probably online, but you'll get the gist when we start drawing the lines. 67 degree wet bulb. So this point is right here. So what happens is as this air travels through the cooling coil, it moves in the horizontal direction and does sensible cooling. At some point, it starts dipping down and doing sensible and latent cooling. And this would be a cooling and dehumidification process on the psychometric chart. In our case, leaving at 52. Again, if that's too cold in this space, we would add some degree of reheat, which is denoted by this line. Again, if you have modulating reheat, you can hit any point on this line that's required to achieve the desired space temperature set point. Of course, there's a little fan heat in there as well. So as our previous example showed, this was 68 degrees blowing into the space. So any comments on that, Eric?
I think we got that one covered.
Okay, good deal. So if we looked at the dehumidification, so how does just heating and cooling work, right? Like we looked at this line before, which is 55 degree dew point. Anything above that, we're in dehumidification mode, which we've just explained. So anything below that, we're in almost standard heating and cooling modes. If it's 72 degrees set point in the space, anything to the right of the space, we would be cooling the air. Anything to the left of the 72 degree set point, we would be heating the air. So that's it's actually a little more complex than this. I'm giving you a very basic, there's actually something called event mode in there and some other things going on, but this is a very basic general. If you're here on the psych chart, we do this. If you're there, we do that. Any comments, Eric?
Yeah, even with your vent mode, if you're to the right of your 72 degree set point, you're still going to need cooling. It's just where does the cooling come from at that point in time? So
right,
nothing really changes there based on the ventilation mode. It's just the method of providing the cool in the space at that point.
So if it's cool and dry outside, we would make a choice between the compressor and the outside air.
Yeah, and the outside air would clearly win every time because it doesn't take any additional energy to pull that outside air in versus running a compressor.
That's right. Cool deal. Okay, so again, our goal is, to control temperature and humidity, and do that over all load conditions if we want to do it right. So I picked some extreme temperatures. So let's say we have this air coming into a unit that could be anywhere from -20 to 115. It could be with outside that range. I just picked some arbitrary ranges there. And we want it to leave between 52 degrees and let's say 85 with a low humidity content. So in my experience, there's 3 things you must have in your unit to make sure this works right. One is a way to modulate the compressor. Okay, on-off compressors will not achieve this goal for you. You need to have a digital or VFD modulating compressor. The other component you will absolutely have to have is modulating reheat. If you have on-off reheat, which I've used in the past in certain applications, but in most applications you want to have modulating, or you'll get wide temperature swings when it tries to reheat. The other thing you're going to need is a modulating heating coil. We didn't talk a lot about heat, but the same scenario applies. If you have 2-stage heat, you're going to get big temperature swings. If you have modulating and you need more precise control, that is going to give you that. And the other component you may need, which I didn't talk about much, is a humidifier. So you may need to add humidity to this system as well. So your thoughts on that, Eric? Any comments on that?
A couple of them. Let's start with the humidifier. If it's really -20 outside, you probably are going to need a humidifier if it's a space that you can't have too dry. Mm-hmm. The other one, I want to come back just to briefly on the modulating everything, where we modulate the compressors, we modulate the reheat, we modulate the gas heat when you need heating. The biggest advantage to that in your average comfort cooling application is the temperature and the humidity in the space are very consistent. And if you've got a 72 degree set point, some people are going to think 72 is a little bit too cool. But they can have a sweater at their desk and put on a sweater when they get too cool. And if it's consistent all the time, it works quite well. If it swings very much, well, they're going to be too cool. And then 2 minutes later, they're going to be too hot with that sweater on. And nobody's ever really comfortable. So it gives you some huge advantages in perceived comfort level within that space.
Lots of space heaters and sweaters.
Yep. Good
comments. Okay, so that was our 15-minute quick take and we're going to talk a little bit about Insight Partners, and Eric's going to talk a little bit about what he's got going on. So we actually finished a little bit early there, Eric. We did pretty good. So
All
I'll
right.
have to add a few more slides next time. And we're going to come back and do some more of these. So if you want to follow us, connect with me on LinkedIn, please do that. Or you can follow us on LinkedIn or connect with us and subscribe on YouTube. A little bit about some announcements for Insight Partners, and then I will turn it over to Eric to talk a little about what he's gone on. So we are a representation firm in the Southeast, and we rep major lines, and one of those is AAON, and that's why Eric's here with us. And we have offices in North and South Carolina. We also have offices in Georgia and Florida. And speaking of Florida, we are now hiring in Florida. So if you know anyone who's looking for an HVAC sales account executive job or HVAC sales manager job, please connect with me here on LinkedIn. And you could message me on LinkedIn. If you're watching this in the future on YouTube, my email address is in the video description. So you can email me, text me, whatever you prefer, and I'll be glad to get a hold of you. So another announcement from Insight Partners before I turn it over to Eric. We have just released our new Grow Room HVAC Solutions Guide. It's a, I believe, 16-page manual on grow facilities. So if you're in the grow facility business, if you're an engineer or contractor or an owner, and you need help laying out equipment, sizing the equipment, handling the controls, writing sequences, we are here to help you. We have tons of experience in this. It's becoming a big niche for us. So we are glad to help, and please reach out to me if you need help on that. So so Eric just started a new role as a technical training manager for AAON. I've known Eric for quite some time now, and they've got this new program called Masters of HVAC. So Eric, why don't you tell us a little bit about it? What's going on with this thing?
I'd love to. So the Masters of HVAC class is a class that I'm going to teach, and I'm going to come to you. We teach psychrometrics, we teach fans and fan laws, and refrigerant piping design, and there will be additional topics that will come in a little bit later. I still have to work on getting those put together, and it takes a whole lot of time to get all this done. The psychometrics class takes about 2 days, and we're going to talk about much of what we talked about today after we get done talking about how to make a psych chart, so that we have an understanding of how psychometrics truly works. Because if you understand how it works, if you understand the basics of how that psychometric chart is made, when you go from North Carolina, where you're pretty close to sea level, to Denver, where you're way above sea level, you know how to accommodate for that and how to get a design that'll work in either location. Because there are some significant differences, and that's one of the things that we'll talk about throughout the class. The same rules apply with fan laws, and then refrigerant piping, how to size it, how to design it, how to make a system that will work and work effectively for a long time. If you have any questions about those classes, you can certainly reach out to me. Tony's put my contact information in the description of the video as well. Or contact your local AAON representative. All these classes will be set up through your AAON representatives.
And who's the typical customer of these classes?
Typical customer is going to be design engineers or design build contractors who want a better understanding of the psychrometric systems of their fan systems and how to properly apply these systems, and again, create a design that will work as expected.
Which is a good thing, right? For
Always.
sure. So, and this is manufacturer agnostic, right? It has nothing to do with you're the AAON guy. It's purely engineering, psychrometrics, and or fan laws and stuff like that, right? It doesn't have anything to do with the actual product.
The closest it's going to come to being commercial is I'll probably wear an AAON shirt most days, and there's an AAON logo on just about every slide.
Okay, I locked up again. I don't know what's going on with this camera,
but we're going to talk about the engineering basics of psychrometrics, of fans, and of refrigerant piping. So it's not specific to AAON, it's specific to engineering.
Awesome. Well, my camera locked up again. I'm not sure what's going on with that. So I have something to do after this presentation. So
there you go.
So we got a question from Bree about getting this video. Yes, I will actually put this on our YouTube channel. It's Insight Partners HVAC TV. So you can go check that out now and just subscribe, and you'll see it up there. Yeah, thanks, Sean. I know I froze up again. I'm not sure what's going on with that, but we're about to end here anyway, and I'm going to look at and see what's going on with my camera. So, Eric, thank you so much for joining us, and thank you all for watching. We appreciate your time.
Thank you, Tony, and everyone else. Thanks for listening.
Thanks, Eric. Just hang on a second, okay?